I actually have two GLBP labs remaining for you, not just the weighting and tracking when we're going to do that in a moment, but first a short and important lab on changing the AVG default selection and even the backup AVG default selection. Now, going back to your MAC address studies, the root bridge gets selected by the MAC address table if the priorities are all left by the default. Not the most scientific way to do it. Maybe we don't like the switch that's been selected as the root to be the root, so we learned a couple of different ways to change that. Here, all three routers had the default priority of 100 on the interfaces running GLBP. So router 3 was selected because of its higher IP address, and I have MLS 3 and 2, but I will say router on occasion as well. Maybe we want MLS 2 to be the AVG instead. Well, we did enable preemption on all three devices at the beginning of the lab. So all we need to do is raise the GLBP priority on MLS 2. And let me go ahead and move that over. And here I just ran show GLBP brief on MLS 3. And you can see it is at the default priority of 100, and it is the active router, and the standby is 172.16.23.1. So all is well. We're going to fix that because now we're going to mess with it. All we have to do is go to the interface of this particular router, and we're going to go GLBP1 priority, which is a value you can set from 1 to 255. We're going to set it to 150. Preemption was enabled, so we should start seeing some messages here pretty shortly, and we do. There's a state change message, fast Ethernet 0/0, group 1 state standby to active, and let's see what the result is. And you can see now the AVG is indeed this router, MLS 2, and with the priority of 150, and the standby router is .3. So let's take this a step further and say that we wanted MLS 1 to be the backup. So we're really changing the default selection here. We're going to go over to router 1. Oops, sorry about that. Touchpads. And let's run show GLBP brief to see things from this router's perspective. And you can see at the top the AVG row. It's got a priority of 100. It's listening. The active router is 2 and the standby router is 3. So what we need then is a priority that's less than 150 but greater than 100. And let's go ahead and make that happen. And we'll give that a moment because I think that's all we're going to need. Not yet. It's in speak, so let's give it a moment here to finish cooking. And there we go. So the second show GLBP brief run, and let me space up there a little bit so we can get some more room to work with. You can see the priority was changed to 125 locally, and it's the standby. 172.16.23.12, of course, is the GLBP virtual router interface. And then you've got 172.16.23.2 still as the active, but the standby is indeed the local router. So we're all set there. So now we've not only changed what the default active or primary AVG selection was, we also changed the standby AVG selection. So really nothing to that, and we're going to go straight from there to the tracking and weights lab. And what I'll do is go over to router 3 first, and we're going to make that the boss again. I love to put GLBP1 there. I'm not sure why. Chip in my head, I don't know. So let's give that a moment. And there's our state change. And you can see the local router is again the active router, the active AVG, and the standby router now is 23.1. And let's see if that holds up actually. Yeah, it did not. We wouldn't expect it to. You can see at first 23.1 was still the standby, but of course routers 2 and 1 were still arguing about it at that time apparently. So now, as we would expect, the interface with a priority of 160 on this router makes it the primary AVG. The priority of 150 on MLS2 makes that the backup AVG, and MLS1 is having an inferiority complex because it's neither one of those again. So let's go from here straight into the tracking and weights lab. And we've got this priority straight. Everything is set up there. I want to run show GLBP here for you. the big show command. Let's try that again. Run that once so often. There we go. So we've got the information we've seen here before. The state changes have added up because we've been messing around with it a little bit. Virtual IP address all the same. And let's take a look now at weighting. The default is 100. It's set to 100. And we have something called a couple of thresholds. We have lower 1 and upper 100. Now the default weight of 100, the weight is the value that determines whether a router can be an AVF or not. We were talking about AVG, the AVG role, the first part of this video. Now we're talking about the AVF. And we can use interface tracking, weight, and thresholds to determine that eligibility. So what we're going to do is set this up so if fast Ethernet 0/1 on MLS 3 goes down, it will no longer be an AVF. It'll still be the AVG, and I'm really going to hit you over the head with those to really bring to your attention that these are two separate operations. The AVG selection and then AVF selection, totally separate. So what do we do first when we're going to do some interface tracking? We're going to check that interface, right? Let's make sure it's up and running. And it's up and up. Everything looks good to me. So we will go ahead and get that process started now. What we're going to do first is track that particular interface. If you haven't done this before, it's a piece of cake. And let's go ahead and start that command. And notice this is not an interface level command, this tracking command. So what we're going to use is track object. And I'm going to stick with 1, but you can pick any number you want to, and you can see we can track up to 500 objects. That's a lot of tracking. So let's see. What we're going to do is select an interface to track because, again, the requirement is if fast Ethernet 0/1 goes down, we don't want 3 to be an AVF. So we'll go with interface there. We know what happens if we use iOS help here, right? But I'm going to do it anyway. Every interface type ever invented. So let's stick with fast Ethernet 0/1, and then we have the option for IP parameters and line protocol. And I'll show you IP, and you can see it's just routing. You're checking to see if an interface has IP routing capability. What we're going to do is go with line protocol, and it has no options. So that's our full command. Our tracking object is numbered 1. It is an interface. It is fast Ethernet 0/1, and what we're checking on it is the line protocol status. It's either up or it's down. So let's go ahead and enter that. And we don't need to go into track config mode. Now we need 2 waiting commands on our main GLBP interface, which is fast Ethernet 0/0. So let's go there. And waiting is what we're going to use, and you'll notice the description there at the very bottom of the iOS help output, gateway, waiting, and tracking. And actually, we're going to be doing both. So we will put waiting here, and notice the 2 values here. We have a waiting maximum value, and then just track. So you would think we would go with track here, since we just wrote a track statement. We're going to come back to it and do it, but we're not going to do it first. What we're going to do here, the syntax is a little funny. With the waiting maximum value, we're just saying, what's the highest value we want waiting to have? And we're going to stick with the default of 100. We're going to say that's as high as waiting is going to get. So now you configure your upper and lower thresholds. And I'm going to put my lower one first. And you'll notice that I can't set that higher than 100 now, which makes perfect sense. This is one of those things that when you read about it, you know, it kind of bounces off you a little bit. When you see it in action, there's nothing to it. So I've got lower 95. Now I'm going to set my upper threshold. And what I'm telling you there is, if this is confusing you a little bit, and it's the first time you've seen it, don't worry about it. It's going to be very clear for you in just a moment. And that's the command. So what this command is doing is saying, okay, the maximum waiting value is 100, period. Our upper threshold can't be any higher than that, so I went with 100. Actually, if you put iOS help there, it's going to show you it has to be between 95 and 100. You can't set your upper threshold lower than your lower threshold. You'd be reinventing numbers then, and you'd be reinventing math. And it can't be higher than 100 because that's the upper value, that's the maximum value we set. So what this long-winded statement says is we're going with the weighting value of 100, the upper threshold is 100, and the lower threshold is 95. The next line is going to track it, and what we're saying is when the threshold goes below 95, then we do not want this router to be considered as an AVF. That's what the entire threshold is about. So we've got this command nailed. Now let's go back and we're going to add another weighting command. This time we're going with track. This tracked object number, of course, must match what? I won't even tell you. But we'll put a 1 there. And let's see what else we have here. We have the decrement, and we can set, let's see what the decrements are. 1 through 255 makes sense. The default decrement is 10, and we're going to stick with that because that'll be enough of a decrement then to drop the threshold below 95, and when it does that, router 3 will no longer be an AVF. So let's go ahead and nail that down, and let's verify with show GLBP. Need the full command on this one. And you can see the values right here in the middle that have changed. The weighting is 100. We configured it as 100. Our thresholds are upper 100, lower 95. We're tracking object 1, which is fast Ethernet 0/1. We did that with the track 1 interface command. The state of that interface right now is up, and the default decrement, as I mentioned, is 10. So how can we test this? We're going to test it by taking that interface down and watching the fun. At least we hope it's going to be fun. Let's see what happens. Shutting an interface is guaranteed to bring the line protocol down. And notice the message that we received almost immediately. I'm going to move this over and get rid of the timestamp. First thing we got is a tracking state message. And this is what I was talking about during the syslog video. Even if you haven't seen this before, just remain calm and read what it says. And it's telling us point blank, there's some kind of tracking going on. We're tracking this interface. It even mentions the tracking number of 1. And it says interface fast 0/1. The line protocol has gone from up to down. So now we have all kinds of things going on. And finally here we just got a GLBP state change message. State gone from active to listen. Seems like a lot of stuff going on there. So let's go ahead and run show GLBP brief and see what kind of damage we've done, if any. Now, again, it's very important to note the AVG has not changed. The local router is still the AVG because the weight doesn't have anything to do with that. What we're looking at is this information about our AVFs. And notice now, with the 3 addresses in play, none of them are being handled by the local router. MLS2 has taken over the one that... Apologies for a slight interruption there. What I was saying is that router 3 now isn't an AVF at all because of that tracking. Router 2 is now handling the traffic for both of these MAC addresses. So let's see, and then router 1 is still handling the one it was handling before. So now let's see what happens when we reopen that interface. We have to do any reloading or anything like that. We'll do a no shut. We get a tracking message almost immediately. Interface fast 0/1. Line protocol has gone from down to UP. It just depends on which line you're looking at. But it has gone up. Everything else has gone up. We're kind of waiting on a GLBP statement here we haven't seen yet. And you'll notice at this point, router 2 is still handling both of those MAC addresses, but relatively shortly, because tracking isn't immediate. Yep, there we go. As soon as I said that. Fast Ethernet 0/0, group 1, forward 1, state has gone from listen to active, and now you can see that router 3 is back to handling the traffic for that particular MAC address. So that is tracking and waiting. And I did have a note for you here on the board before we wrap this particular video up. And we're moving to security next, which of course is a huge section on your exam, as it should be. One thing I just want to remind you, and there's a reason I ran this lab on our AVG. It's to emphasize that the AVG election or selection, whichever you want to call it, and a router's ability to serve as an AVF are two separate operations. Use priority to affect the choice of your primary and backup AVGs. Use waiting to affect a router's ability to serve as an AVF, perhaps in tandem with interface tracking, just like we've seen here. That wraps up our look at redundancy and first hop redundancy protocols. What we're going to do now, as I mentioned, is head to security, a huge section on your exam, and of course a huge section in real life. So take a breather, and I will see you there.